Good morning, students. So today we are going to discuss the IIT-JEE NEET foundation. There is a topic in magnetism. So we will go back. See, electricity, magnetism. In the magnetism, see the magnetic field. What is magnetic field? Magnetic field is nothing but, see, first magnetism is the subject which is related with magnets. See, there is attraction, repulsion. The substance which attracted by the magnet are called magnetic substances. The substance which are not influenced by the magnet are called non-magnetic substance. Magnetic substance examples iron, cobalt, nickel. Non-magnetic substance like wood, stone, etc. So there are two different types of magnets are there. One is called natural magnet, another is artificial magnet. Natural magnet is something which is available in the nature like stone, lodestone, etc. See, magnetite ore, Fe3O4, magnetite ore are called the natural magnets. Artificial magnets are nothing but man-made magnets are called artificial magnets like bar magnet, horseshoe magnet, cylindrical magnet, spherical magnet, etc. These are called artificial magnets. They are having certain shape, and so there is certain strength will be there for the artificial magnets. Natural magnets do not have any regular size and shape, and they are available in the earth core. So that is natural magnet and artificial magnets. The magnets have, so there are many characteristics, many properties are there. Magnets have the property like attraction, repulsion. Attraction, repulsion is nothing but, see, there are like poles repel each other, unlike poles attract each other. So this property is there, that is first law of magnetism. Then magnet is also having another important property, pair property. If you cut a magnet into two pieces, it consists of two poles, south pole, north pole. You cannot separate the two poles of a magnet. If you cut into small molecules also, that molecular magnet, it behaves, it consists of two poles. Such property is called pair property. And another one, directionality. What is directionality? If a magnet suspended freely, it specifies its direction. Either north pole represents north direction or south pole represents south direction. So when you suspend a magnet freely, so for example, if you take a bar magnet and so you wound it with help of a rope or something and suspended somewhere, it oscillates for some certain time and comes to the rest in a specific direction. So that represents its direction of the earth. That is called the directionality property of a magnet. So this directionality property only used in, see, marine compass and other areas where compass needle is going to. So we have many applications to know the aviation and navigation directions, etc. So coming to the magnetic field, another important property, that is magnetic field. The space which is surrounded by the magnet, is called magnetic field. See, basically magnetic field is associated with electric fields also, because see, electricity, magnetism, you cannot separate them. You see, without electricity is no magnetism, without magnetism there is no electricity. One is left to right, another is right to left. So that is very, very important phenomena. That's why in the case of magnetism, there is a pole strength. Pole is nothing but the end point of a magnet is called pole. Pole strength is the ability of a pole either which attracts or repel another pole. See, pole strength units are ampere meter. See, pole strength is represented as current here. Pole strength ampere meter. There is certain length and a certain current. So without electricity there is no magnetism. That you should understand. Electrical currents also produces magnetic fields. See, when a current carrying conductor is there, so the which is surrounded by it is magnetic field, like a concentric circles around the conductor. Bar magnet has these are the magnetic lines. See, magnetic lines are nothing but imaginary lines which are drawn from one point to another point in a magnetic field. The imaginary lines which are drawn from one point to another point in a magnetic field are called magnetic lines. If you take a conductor, when a current passes through the conductor, these lines are called electromagnetic lines. The electromagnetic lines which are surrounded like a concentric circle around the conductor. So these are all. So current carrying wire, when a current is passes through the wire, a loop of wire, when see current is passes through the some loop, like loop is nothing but something like a wire if it is arranged in the certain shape like coil. See, coil and conductor different, you should understand. Coil means the same conductor you are arranged into a some rectangular or circular so shape, that is called coil. Here loop is also similar to that. It is a circular loop, means the conductor you are arranged into a circular shape, that is called loop, or see something like a coil. When current passes through this coil, the magnetic field is going to be like this. This is solenoid, like a spring. So the wire is continuously, it is there here, okay, it is like this. There is a magnetic field in the solenoid. Magnetic field of a solenoid and magnetic field of a bar magnet are same. Magnetic field of a solenoid and magnetic field of a, see this is solenoid magnetic field and this is bar magnet magnetic field. Both are very similar. See, if you observe here, see the solenoid, one end it is behaving like a north pole, another end it is behaving like a south pole. Bar magnet is also north pole and south pole. See, usually magnetic lines characteristics, if you take, all magnetic lines starts from the north pole and reaches the south pole and comes back to the north pole through the material. They are closed loops. Magnetic lines are closed loops. Similarly, in the bar solenoid also, it starts from the north pole and comes to the south pole and comes back to the north pole. See, this magnetic intensity will be maximum at the poles. Here maximum intensity will be there. In the middle, very less. For solenoid also similar. So there is similar characteristics will be there for solenoid, and as well as solenoid is a something like a coil which is like a helical spring. When current passes through that, so it behaves like a magnet. It behaves like a magnet. So that is the difference between solenoid and magnet. So solenoid is a something helical spring, which current carrying spring. So when current passes through that, current changes its direction continuously. Due to this, the one end behaves like a north pole, another end behaves like a south pole. Due to, see, this is like a bar magnet magnetic field which is going to be there. So it starts, the magnetic line starts from the north pole and reaches the south pole and comes back to the north pole through the material. So that is why, and if you take, this is the earth magnetic field. In the earth magnetic field, the earth is also consists of, there is a geographical north pole and a magnetic north pole. There is a different. Geographical north pole and magnetic north pole are not near each other. Geographical north pole near to the magnetic south pole. Similarly, geographical south pole is near to the earth magnetic north pole. So these are the two things important, because earth is also a huge natural magnet. Earth is also a huge natural magnet. The magnetic fields of the earth is also just like bar magnet, all this, okay, so magnetic field will be there. So this is about magnetic fields. See, the magnetic field, if you observe here, the value, if you, because the magnet has properties like magnetic induction is one important property. See, the magnetic induction is nothing but, see, there is a temporary magnetism of an iron piece when it is bring near to the magnet. See, it is a magnetic induction is a property which explains about, see, the magnetic force upon pole strength, the force upon pole strength. See, that it explains the magnetic, what will be the strength. It is something like magnetic induction. Induction is nothing but, so the ability of a magnet, how much it can do, that it is denoted by capital B. Capital B, the units are Tesla. Tesla is the unit, SI unit, and Gauss is the CGS unit. Tesla is the SI unit, and so the magnetic induction has formulas. The magnetic induction has the formula like capital B is equal to force upon pole strength. This is one formula. Magnetic induction is equal to force upon pole strength. There is another formula, magnetic induction is equal to magnetic flux by area. Magnetic flux by area. So the units are, magnetic induction units are Tesla. Tesla is the SI unit and Gauss is the CGS unit. 1 Tesla is equal to 10 to the power of 4 Gauss. 1 Tesla is equal to 10 to the power of 4 Gauss. This is one important. The SI unit of magnetic, of course it is magnetic field or magnetic induction. Both are similarly we will represent. So that's why 1 Tesla is 10 to the power of 4 Gauss. And CGS units, if you take, CGS unit of magnetic induction is Gauss. 1 Gauss is nothing but, see, 1 Maxwell per cm square. 1 Tesla is equal to 1 Weber per meter square. Weber is the SI unit of magnetic flux. Weber is the SI unit of magnetic flux. So Weber per meter square, Weber per meter square is called Tesla. Weber is 10 to the power of 8 Maxwells. 1 meter square is 10 to the power of 4 centimeter square. So 10 to the power of 8 by 10 to the power of 4, that 10 power 4, that is nothing but this 10,000 Gauss. 1 Tesla is equal to 10,000 or 10 power 4 Gauss. See this important, see basics of magnetism. Magnetism is a huge concept. It is a very important concept in the physics. See, magnetism, electricity, gravitation, all are very related topics. If you are solving one problem in magnetism, it may be related in gravitation also. Similar model problem it may come. In electricity also similar model problem. The formulas and everything will be similar. If you take gravitation, Newton's law of gravitation is there. Similarly in magnetism, inverse square law of magnetism is there. Similarly in electricity, inverse square law of electricity is there. All three are very related each other. So very similar formulas, only difference constants. In the electricity we will use electrical constant. So in the gravitation, gravitational constant. In magnetism constant. That is mu naught by 4 pi, permeability in the free space divided by 4 pi. We will discuss more clearly in the next video. See notes on some units, magnetic fields. So we will continue in the next video. Thank you very much.